Hey, good morning everyone. Welcome back again. I hope you all are doing good. Okay. So today our topic of discussion is pseudo force. When I was teaching you the relative motion topic, then I told you that the theme or the concept is that whenever multiple objects are moving and you stand on any one object as a platform or frame of reference and then you observe the other one. Okay. Similar topic, but all the questions that can be done by using the relative velocity thing can also be done without using the relative velocity. So in our discussion, we can say that we are going to use relative velocity topic as a tool or a technique to solve the problems. Similarly, our today's topic of discussion will be a pseudo force topic. Fictitious force, pseudo force, what is that exactly, when it comes, why it is necessary to consider that. All these things we will discuss. But throughout the discussion, you remember this thing that all the questions that can be done with pseudo force can also be done without pseudo force, which means in our scope of our NEET 2026 preparation, we are basically going to consider the pseudo force as a tool or a technique to solve the problems. So when I say that is to be considered as a tool or a technique, so no one is going to ask you in the exam that solve this problem or determine this result by using pseudo force or not by using pseudo force, which means it is totally dependent on our understanding, our comfort, that whether we want to use this technique or we don't want to use the technique in order to solve the same problem. So when I'm teaching you this and when I'm telling you that it is going to serve as a technique, which means it is going to concise your solution, reduce the size of solution, making the analysis of the physical situations easy. Okay. But before that, I mean, in order to, appreciate the beauty of this topic, definitely you have to, first of all, get into the depth of the topic. Okay. So let us start. So the topic of our today's discussion is pseudo force from the unit Newton's laws of motion. We are going to consider it as a tool or a technique to solve a variety of problems in mechanics. But when we can consider it, like every question we can't apply, right? Relative motion, we can't apply pseudo force. So in what situations we can apply that we are going to discuss here first. Okay. So first of all, why there was a need of pseudo force? Why, when, how the idea came into the picture, so that we are going to discuss as a concept of pseudo force. So suppose there is an object. It is kept on a table or a horizontal surface. There is a 5 kg object and it is at rest. Okay, this object is at rest, not moving. Okay, this object is at rest, it is not moving anywhere. So now there are two observers. Observer 1 is also not moving, at rest. Observer 1 is not moving, this is at rest. Observer 2 is moving in the forward direction. Observer 2 is moving in the forward direction with a constant velocity of 10 meter per second. 10 meter per second. So basically, I am assuming it to be moving with a constant velocity. Constant velocity. All right. And there is an observer 3. Observer 3. This observer 3 himself is moving forward with an acceleration of 10 meter per second square. With an acceleration of 10 meter per second square. So it is basically a constant acceleration. Constant acceleration. Okay. So this is an object which is at rest. This is an object which is at rest. This is a situation. This is a situation given to you, that there is a 5 kg object placed on a horizontal table which is at rest right now, but there are 3 observers, those are in front of you. These 3 are the observers, those are in front of you, and I'm going to see one by one that what are these observers observing. According to these observers, what will be the observation? What will be the observation? Situation is in front of you. Okay, but according to these three observers, what will be the observation? So block is at rest, observer 1 is at rest. So block is in front of me, I am also standing. So what I will observe? I will observe that with time, the block will be maintaining its position. The block is not going to go anywhere, which means its observation will be exactly the same, that this 5 kg object is at rest. If the object was actually at rest and the observer is also at rest, so definitely there is no relative motion, no relative velocity, no relative acceleration, no relative displacement. Hence, you will say that this is going to be the situation. Since it is at rest and it will maintain its position of rest, so here I will say the net force acting on the body will be 0. The net force acting on the body will be 0. Here actually the net force acting on the body was 0 only. Here already at rest means the net force acting on the body is going to be 0. It is basically static equilibrium. Means the body is in equilibrium, that too static equilibrium. It is not going anywhere. It is not going anywhere. Okay, static equilibrium. Now observer 2. According to observer 2, if you observe, so the block is at rest. Suppose the board is at rest and now I am the observer 2 and I am moving ahead with 10 meter per second. I am moving ahead with 10 meter per second. So according to me, the body which was at rest will start moving back. See, the body is at rest but me as an observer are moving forward. I am walking on the ground. So the trees, the plants, the benches on the ground, according to me, they will be observed to be moving back. Okay. In that case, I will say that here this 5 kg object will be observed to be moving back with 10 meter per second. It's a constant velocity. Here velocity is observed to be constant. So if velocity, the observation I am writing, here velocity vector according to this observer is constant, which means acceleration vector is 0, which means the net force acting on the object according to this observer is 0. See, in actual situation also there was no force, but according to observer 1 also, it directly observed the actual situation, there is no force. Here according to observer 2 also there is no force acting, on this 5 kg. But if you observe this, like if you are the observer 3, and you yourself are accelerated in the forward direction, then the rest of the world will appear to be moving in the backward direction, appear to be accelerated in the backward direction, which means if I say that this is 5 kg and it is moving with 10 meter per second square, 10 meter per second square. So the net force on block as per observer 3, the net force on block as per observer 3 is non-zero here. It is not 0. Why, sir? Because the observer 3 will observe that the block is accelerated back. When the observer 1 was at rest and the actual situation was that for rest, then nothing happened here. You will say that, in this case, the object which was at rest is observed to be at rest. So the net force is 0. Actually net force is 0. Here also net force is 0. Here also net force is 0 because observer was moving with constant velocity. So the relative motion observed is also with constant velocity. But here if observer is himself accelerated, if observer is accelerated, then the relative motion observed will also be accelerated motion. If it will be an accelerated motion, then there will be an observed force which was not actually existing, but it is observed to be existing. There is no actual net force here, but there will be a net force observed here. This observed net force, which is not the actual force, is basically called pseudo force. Okay, so how do we write that? We write it as mass of block, that is 5 kg, mass of block, that is 5 kg, into minus of acceleration of the observer. Mass of block into minus of acceleration of the observer, because the force is observed to be acting on the block. Force is observed to be acting on the block, so the mass should be taken of block. But the observer will observe that the block is accelerated opposite. So that's why there is a minus. And opposite with what? If observer is accelerated with a 10 meter per second square, the object will be observed to be accelerated with 10 meter per second square only in the opposite direction. So that's why you are writing mass of block into minus of acceleration of observer, or that is called the frame of reference. Magnitude wise, if you calculate, so that's going to be 5 into 10 minus 50 Newton. Minus 50 Newton, this minus is only showing towards left. Minus is only showing towards left. I hope that's clear to you. Now, if you understand that carefully, what happened exactly here, the situation in front of you was given to be this, okay? And I am saying that when your object was actually at rest, and in these two cases it was also observed to be at rest, there is no requirement of any fictitious force or any pseudo force or any additional force, okay? They were in equilibrium, they are observed to be in equilibrium. So these frame of references where the Newton's second law can be directly applied, or whatever you observe is reality, these are called inertial frame of references. Inertial frame of references in terms of force I'm categorizing. I'm not talking about the relative velocity. Relative velocity is already done. Now, somehow our topic of discussion is based on relative acceleration. Relative acceleration, okay? Because force is responsible to produce acceleration. So if the object was not actually accelerated, but it is observed to be accelerated, and when the object will be observed to be accelerated, when observer himself will be accelerated frame of reference. So whenever the observer himself accelerates, we have to consider a pseudo force applied on the object. Whenever observer is himself accelerated, we have to consider a pseudo force applied on the object. The direction of pseudo force will be opposite to the acceleration of the observer. When you write that pseudo force as m into a, the mass will be always that of the object. The acceleration will be always that of the observer. The mass will be always that of the object. The acceleration will be always that of the observer, but in opposite direction. All right. So these two frame of references, when the frame of reference is initially either at rest or moving with uniform velocity, these two frame of references are called inertial frame of references. Inertial frame of references. And this frame of reference, when it is accelerated frame of reference, this is basically non-inertial frame of reference. This one is non-inertial frame of reference. Once again, frame of reference or observers are considered like this, that if the frame of reference means with respect to what frame you are observing the motion. So if your frame of reference or observer is either at rest or moving with a uniform velocity, those frame of references are called inertial frame of references, where Newton's second law can be directly applied. If the observer or frame of reference is himself accelerated, then those frame of references are called non-inertial frame of references. You can apply Newton's second law only after considering the pseudo force. The pseudo force is applied on the object always opposite to the direction of acceleration of observer. And when you write the formula of pseudo force magnitude wise, like F is equal to ma, then that m should be the mass of the object, but that a should be the acceleration of observer. But as I mentioned, it should be in opposite direction. I hope the story is clear to you. All right. So that's the basic concept and feeling of pseudo force. When the pseudo force comes into the picture, why the pseudo force comes into the picture, and how the pseudo force comes into the, like how to apply the pseudo force. I think all the stories are clear to you. All right. Let me take you towards the detailed discussion of types of frame of references Theoretically. So there are two types of frame of references. One is non-inertial frame of references. Let me take first of all the inertial one. Inertial frame of references. Okay. Non-inertial frame of references. Now here I would say that let me distinguish between them very nicely, that how do we define them and how do we deal with them. How do we define them and how do we deal with them? Okay. So, right. Now, if I particularly talk about the inertial frame of reference, so I will say acceleration of frame of reference must be 0. Acceleration of frame of reference must be 0. That is either observer is at rest. Observer is at rest or moving with a uniform velocity. Either the observer is at rest or moving with a uniform velocity. But so when I say acceleration is 0, I don't mean that it has to be at rest. It might be at rest, it might be moving with a uniform velocity. It must not be accelerated, because when we talk about the non-inertial frame of reference, acceleration of frame of reference is non-zero. That is, observer is accelerated. Observer is itself accelerated. I hope that's clear. Now, if I talk about the dealing, like how do you deal such kind of problems or such kind of problems? So I say that here Newton's second law can be directly applied. Newton's second law, actual version can be applied. Actual version can be applied means, that's it, F is equal to ma. That is, F external will be equal to mass of object into net acceleration of the object. F is equal to ma. F is equal to ma you are applying for the block, for the object here. But here if we talk about Newton's second law, if we want to apply Newton's second law appropriately, then Newton's second law actual version cannot be applied. Here modified version can be applied. Modified version can be applied. Okay. What do we mean by modified version, sir? What is that modification? That modification is the consideration of pseudo force. That is, you will say F external plus F pseudo. F external plus F pseudo, that will be equal to mass of object into acceleration of the object. Where this pseudo force is equal to mass of object into minus of acceleration of observer. Remember the rules. That is mass of object into acceleration of the object which you observe. Okay. Here it is mass of object into minus of acceleration of observer. If you want, you can also take this negative on that side. So what you will get is mass of object into acceleration of object vector plus acceleration of observer vector. But remember, vector formula ke according to the vector formula, or vectorially speaking, that you are going to add these two vectors. But with the situations, with the numerical problems, whenever you will substitute, you will again substitute along with the plus minus sign. Our convention in x-axis, forward positive, backward negative. In y-axis, upward positive and downward negative. Alright, that's the case. By definition, just attaching a small point here. By definition, Earth, see, Earth is also, rotating about its own axis, revolving around the sun. So it is basically accelerated frame of reference. By definition, Earth is also non-inertial frame of reference. Earth is also non-inertial frame of reference, but if object and observer both are at rest on the ground, if object and observer both are at rest on ground, okay, that's previous year IIT JEE advanced question, that by definition Earth itself is considered to be a non-inertial frame of reference because its revolution is there, right? It is in circular motion. And today also we will consider, obviously, whenever a body is in circular motion, it is always accelerated. Previously we have also discussed this, the centripetal acceleration thing. So by definition, Earth is also non-inertial frame of reference, but if object and observer both are at rest on ground, then we don't apply pseudo force. We never apply pseudo force. I hope you will remember this point. It's a small theoretical point which I have mentioned, but since that has already come in the JEE previously, there is a high chance that you can observe such kind of tricky statements in the NEET part also. All right. So I hope the idea for inertial and non-inertial frame of reference is clear. The feeling behind that I already told you. I hope everyone is able to feel the emotion I was sharing with. But here I'm talking about the theoretical aspect, that what is inertial and non-inertial frame of reference, how we can apply Newton's second law, actual version and modified version in the case of non-inertial frame of reference. The modification involved is consideration of the pseudo force. Pseudo force is always applied on the object when the observer is accelerated. Pseudo force is always applied on the object opposite to the direction of the observer. And when you write it mathematically, F is equal to ma, the m should be the mass of the object, whereas a should be the acceleration of the observer. M should be the mass of the object, a should be the acceleration of the observer. That's the entire story. All right. Any observer or any frame of reference which itself is accelerated is categorized under non-inertial frame of references. So pseudo force must be there. But the situation with Earth is that by definition, Earth or ground is also considered to be the non-inertial frame of reference, but there is no relative acceleration. If an observer is also standing on the ground and object is also standing on the ground, then the Earth, observer and object, everything is revolving around the sun. So everything is non-inertial. But there is no relative acceleration between the object and the observer, and hence there is no need of applying pseudo force. You can go ahead with the actual version. I hope the logic is clear. All right. Chaliye. Let's move ahead. Now we will talk about the concept of apparent weight. Apparent means observed. This term apparent means observed, weight. Okay. So basically you want to talk about observed reading of normal reaction. Observed reading of normal reaction. Now what is this, sir? That N or R. So what is happening whenever you go and stand over a weighing machine? Whenever you go and stand over a weighing machine, you compress the spring, or you apply some force because of your weight on the surface of the weighing machine, or you will put some extension if you are hanging. Okay, there can be a weighing machine over which you place something, or there can be a weighing machine from which you hang something. So either it will be a compression in the spring below your feet or the extension in the spring above your head. In both the cases, you have to consider the reading. The reading of the spring or normal reaction is going to give you your weight. Okay, because actually your mass and acceleration due to gravity, mg, are not changing. So your actual weight is not changing, but your observed weight or apparent weight changes. For example, if you go inside the swimming pool, you feel light. Okay, and if you are actually floating, which means your observed weight is 0. Your actual weight mg is still there, but there is a buoyant force also acting. So actual weight is still there, it's non-zero, but because of the action of buoyant force, which balances your actual weight, you say your observed or apparent weight is zero. Your observed or apparent weight will come out to be zero. So here also we will talk about the observed weight. Now I have taken number of case studies. This is the first case study, that is concept of apparent weight in lift and or elevator. What is the difference between lift or elevator? There is no difference of physics, there is a difference of English. Lift is basically British English. Okay, British English, which you and I use. Okay, elevator is basically American English. So why I am telling you this? Because people oftenly get confused in elevator, escalator. Escalator means the automatic staircase. You know, in metro stations, in malls, you go and stand there and automatically you reach the above floor. So the moving as staircase, the automatic stairs there, steps, automatic steps, that is the meaning of escalator. Here it is elevator. Lift and elevator means the same. The lift you have in multi-story buildings, hospitals, malls, schools, right? So the only difference is the English. There is no other technical difference. Okay. So coming back to the topic, in order to study, as I have said that I have taken multiple case studies, multiple headings, where the pseudo force application you will observe. In all the cases, I will keep on emphasizing on the point that pseudo force is a tool or technique. Any case study or any problem that can be considered with pseudo force can also be considered without pseudo force, which can be considered with pseudo can also be considered without pseudo. Okay, so let's talk about it. So first of all, case 1, the elevator is at rest. Okay, the elevator is at rest or moving uniformly. It is at rest or it is moving with constant velocity. When it is moving with constant velocity, it can move in any direction. That is, it can be moving like this, like this, like this, like this, like this. It can be moving in any direction so far. Okay, V cap. V cap is this. V cap means the direction of velocity. That is the situation. There is an m0 mass object and I want to observe this m0 mass object. I want to observe this m0 mass object and I want to see how many forces are acting on it. So there are two observers. One is the observer which is inside the elevator and just seeing the block placed there, kept there. And there is another observer which is on the ground. There is another observer, observer 2, which is on the ground. Okay, and we will analyze, we will try to see that with respect to these two observers, what is the observed weight. See, remember, actual weight is still W is equal to mg. We want to talk about the observed weight here. So I will say that, suppose I talk about observer 1. Observer 1. Observer 1 himself is inside the elevator, but the acceleration of the elevator is 0. Acceleration of lift is 0. Or observer 1 is 0. Which means inertial frame of reference. So you can directly apply inertial frame of reference. You can directly apply Newton's second law. If you want to directly apply Newton's second law, this implies you will observe that on this block there is one force W equals to m0 g here, one force W equal to m0 g here, and one is the normal reaction. This normal reaction N or R is the R1 reaction. R1 reaction here, or you can simply say this is N or R, N or R normal reaction. Okay, so I will say that since it is not moving anywhere, it is at rest or V constant. If it is at rest or V constant means acceleration is observed to be 0. The observer is not accelerated. The block is also not observed to be accelerated. So you will say net force is going to be 0, which means net upward N or R must be equal to net downwards m0 g. This implies your apparent weight will be equal to your actual weight. Your apparent weight will be equal to your actual weight. That is your conclusion here. This is what you have concluded from here. Now what I am trying to say is that even if you observe the same situation with respect to observer 1 or you observe the same situation with respect to observer 2, the conclusion is going to be same. And I understand that in case 1 you will not understand everything, because these things, whatever I am writing in front of you, seems too obvious for you, that oh, we know it, sir, we have been doing it, sir, what's the point of dealing with this topic separately today? So let me write down case 1, case 2, case 3, everything in front of you, and then we will discuss how much you have understood. Okay, so now if I talk about observer 2, from observer 2, which is already at rest on the ground, observer 2 is already at rest on the ground. So if it is already at rest, it is anyways by default it is inertial frame of reference. If it is inertial frame of reference, again you will see the forces acting on the block, and you are going to apply the Newton's second law. So the forces acting on the block according to this observer is also W equals to m naught g, and here also it is n or r. Okay, and the acceleration is 0. The acceleration of lift is the acceleration of block is observed to be 0. Okay, so if you consider the acceleration of the block observed to be 0, now here what I can write is, according to this observer 2, the forces acting on it are n or r upwards minus m naught g downwards. That must be equal to 0 because the net acceleration is 0. This implies you will say n or r will be again equal to m naught g, or your apparent weight must be equal to your actual weight. Your apparent weight must be equal to your actual weight. See, again and again I am concluding the same thing. And right now it is observed for you, sir, both the things, the blue colored part and green colored part are almost same only, na? Yes, they are same because the lift was not accelerated. So whether the observer is standing within the lift or the observer is standing outside the lift, in this situation both the observers are inertial frame of reference. So I didn't discuss in any of the cases the existence of pseudo force. But now if you compare this case 1 with case 2 and case 3, which I am going to write, then definitely you will be able to distinguish between them. So let me write case 2 for you. In this case 2, I will say that there is this elevator, there is this m naught, this is observer 1. And say the acceleration of lift is upwards, a naught. The acceleration of lift is upwards, a naught. So if an observer is standing inside the lift, then the acceleration of the observer 1 as well as the acceleration of the a naught, acceleration of observer 1 as well as the acceleration of a naught, these are going to be same, and that is the acceleration of lift, these are going to be a naught. And there is another observer here, this is observer 2, which is at rest on the ground. This is observer 2, and here since the observer is at rest or observer is in uniform motion, basically observer is accelerated 1, which means non-inertial. Observer 2 is at rest on the ground, which means inertial. That's what we have learned. Now let us try to understand how to distinguish between them. So if I talk about observer 1, what is his observation? So I will say it is a non-inertial frame of reference. In this case, you will say that the forces which you observe are basically these. See, the forces which you observe is, there is one W equals to m naught g downwards, there is one normal reaction n or r upwards. Now, since the observer is accelerated up, the pseudo force on the block will be acting down. So there will be a pseudo force also acting down, and that pseudo force will be mass of object m naught into acceleration of the observer or lift a naught. Mass of object into acceleration of the observer. Let me write it as AL, so that you will remember that I'm talking about the lift. Okay, I'm talking about the lift. Did you understand? Sir, why you didn't keep a minus sign? Because minus sign of pseudo force is only denoting the same thing, that pseudo force is always applied on the object opposite to the direction of the acceleration of observer. So pseudo force is applied on the object opposite to the direction of acceleration of observer. Observer was accelerated up, so pseudo force is acting down. All right, simple. Now, according to this observer, observer 1 is inside the lift. The block is also in front of him. So according to this observer, the block is observed to be at rest. Block is observed to be at rest. That's the feeling. That's what the observer is feeling. Observer is observing. So in that case, net upward force must be equal to net downward force. Net upward force N or R must be equal to net downward force. है ना? Net upward must be equal to net downward. So can I say that here net upward must be equal to net downwards? So you will say N or R will be equal to M naught. If you take common, it is G plus AL. And clearly your N or R means normal reaction, that is the observed weight or apparent weight, and mg is the actual weight, but it is m of G plus AL. So it is greater than W actual. It is greater than W actual. I hope this logic is clear to you. Okay, this is what you are observing or you are concluding only if you are an observer standing inside the lift. But in the same situation, as I always say, all the situations that can be considered or analyzed with pseudo can also be analyzed without pseudo. In the same situation, you want to observe the same block, but this time you don't want to observe the block by going inside the elevator. You want to observe the same block, same situation, but being an observer standing at rest on the ground. In that case, what will happen, sir? So if I want to consider his observation, then his observation, he is going to be inertial frame of reference because it was at rest. So no pseudo force. No pseudo force, then what he is observing on the block, he is observing that there is some W equals to M naught G on the block. There is a normal reaction on the block. There is no pseudo anywhere because the observer is not accelerated, and he observes that the block is accelerating up along with the lift. For observer 1, the block is always in front of him. So at rest, block was observed to be at rest according to observer 1. But according to observer 2, who is standing on the ground, the block is accelerated up along with the lift. So block is observed to be accelerated up. Block is observed to be accelerated upwards. If block is observed to be accelerated up, so you will say dominating, like this is its acceleration AL. So you will say bigger minus smaller N or R minus M naught G, that will be equal to M naught into AL. Okay, this implies N or R. Again, what you are going to get here, that is M naught G plus AL. G plus AL. Is that clear what we are discussing here? We are discussing that if the object or elevator is accelerated up, the apparent weight comes out to be greater than the actual weight. The observed weight comes out to be greater than the actual weight here. Okay. If the lift is at rest or moving with the uniform velocity in any direction, horizontal, diagonal, up, down, anywhere, okay, then the actual weight and apparent weight are same. If the elevator is accelerated up, the actual weight is the apparent weight, the observed weight is bigger than the actual weight, which means you will feel heavier. Your feet, your legs will feel heavier if you are accelerating up. But if you are accelerating down, case 3, if you are accelerating down, okay, so what is happening? That there is a block of mass M naught the lift is accelerating down AL. This is observer 1 here, which is himself in the lift. So according to observer 1, block will always be in front of his eyes. So there is no motion observed. And here there is observer 2, which is at rest on the ground. Rest on ground. Resting on ground. Okay. So now we will see what these two will separately observe. So according to this observer, I will say, since it is accelerated down, there will be a pseudo force acting up. There will be a pseudo force acting up. There will be a normal reaction acting up. And there will be a weight acting down. And the acceleration of the block, acceleration observed, is 0. Observed. Acceleration of block is observed to be at rest. Block is not actually at rest. But according to this observer, block is observed to be at rest. So I will say net upward must be equal to net downward. If net upward must be equal to net downward, N or R plus pseudo, that is equal to W. This implies N or R, which is the apparent weight, that is equal to W minus pseudo. So which implies N or R that will be equal to M of G minus AL. G minus AL, or you can say W apparent observed weight is less than the actual weight. Observed weight is less than the actual weight. That's what you have concluded. So if the observer is accelerated down, please mind it, I'm not talking about where the observer is moving. I'm talking about where the observer is accelerated. I repeat, I'm not talking about where the observer is moving. I'm talking about where the observer is accelerated. So if the observer is not at all accelerated, there will be usual feeling on your legs. Your actual weight and your apparent or observed weight is going to be same. If the observer is accelerated up, then because your if the lift is or block is accelerated up, then your apparent weight or observed weight is higher than the actual weight. Higher than the actual weight means your legs will feel heavier. You will get tired. And when the object is accelerated down, sir, where is the observer? That doesn't matter, because whatever the conclusion you will get by observer 1, the same conclusion you will get for observer 2. Okay, their observations are different, their rules are different, but the conclusions are going to be exactly same. So if the object is not accelerated, then apparent and observed are same. Apparent weight and actual weight are same. If the object is accelerated up, then definitely you will feel heavier. If the object is accelerated down, you will feel lighter. You know, when the lift is accelerated down, you feel lighter. You know, you feel butterflies. So basically, in that case, again, I am saying what object is doing, that matters. Where is the observer? That doesn't matter. The only thing is they will have two separate type of analysis. One will be inertial frame of reference, one will be non-inertial frame of reference. But all the questions that can be done with pseudo can also be done without pseudo. All the situations which can be observed with respect to an accelerated observer or non-inertial frame of reference, the same situations can be observed with respect to inertial frame of reference or an observer who is either at rest or moving with uniform velocity. I just kept it very fast because I have been talking about all this since the starting of the interaction. So that is the situation. Now suppose you say that, what about this observer, sir? What about this observer? This observer is inertial observer, inertial frame of reference, because it is not accelerated anywhere. It can be either at rest or it can be moving uniformly, but it is not accelerated anywhere. Now, if I am the observer standing on the ground, the block is kept inside the lift and lift is accelerated down. So if the lift is accelerated down, according to me, the block is also observed to be accelerated down. So in that case, I will say this will be M naught G. There is no pseudo, there will be a normal reaction R, and the acceleration of lift is downwards. In that case, you say bigger minus smaller in the direction of bigger one. So that is M naught G minus R, that will be M naught AL. If you rearrange, you will get N or R, that is equal to M naught G minus AL. N or R is equal to M naught G minus AL. That is the conclusion. That is the conclusion. See, The same conclusion, you will feel lighter. The same conclusion here, you will feel heavier. The same conclusion, you will feel usual. Okay, observed or feeling is more, means you feel heavier. It is less, you feel lighter. If apparent or observed weight is equal to the actual weight, you feel usual, your day-to-day life experience. I have written a lot on the in this slide because of the two reasons. Reason number one, so you can do the clear-cut comparison in case 1, case 2, case 3, when you feel heavier, when you feel lighter. Reason number 2, you can also understand the logic that all the things that can be concluded with pseudo can also be concluded without pseudo. Slowly going forward, you will understand pseudo force applying pseudo force is a very beautiful and important tool and technique. Okay, so right now, what you know earlier without pseudo, I am also introducing pseudo. Slowly, I'll keep only talking about the application of pseudo and I'll forget what we learned earlier. Okay, then in problem solving, you will be able to choose any of the approaches according to your comfort. So I'm just, going off screen. You pause this slide or just take a minute, go through this. If you're attending this live session, go through this, take a minute or two, go through everything written in front of you. Hi Sachin, hi others. Yeah, so I get 483 marks, any MBBS seat in AU region, OC category in Andhra Pradesh. That you have to see 483 marks. I think it will be definitely a safe side marks. You can expect something. Okay. Sachin, offline classes. Okay, regarding the offline classes also you will be informed separately. Don't worry about it. Right. And this is an online bridge course going on. Go through everything written in front of you. Each and every fundamental. Have two types of comparisons. Comparison 1 between case 1, case 2, case 3. Comparison 2 between in each case with pseudo, without pseudo, except case 1. In case 1, since the lift is not accelerated, so whether you stand inside lift or you stand outside lift, in both the cases, you are dealing with inertial frame of reference, so no pseudo force anywhere. But still go through everything. Are we done? Review nicely. So this much is the case 1. Then these are the two cases, pink colored and orange colored for case 2. And then the blue colored and green colored for case 3. I know it's too much on a single slide, but can't help. I wanted to share the entire story in front of you so that you can keep the links connected. That's why. Manage it a bit. Hi Preeti, Prakash. Students, we have already talked about the cutoffs and expected things in a separate video. Okay, so here we don't want to entertain any distraction from the concept. Let us today right now focus on the concept about the cutoff and everything. I really understand the concern. I would really be happy to help you, but in some other interaction. Okay, I hope you understand. Okay, chalo. Let me take you towards the next case study. This was the application, the core application of pseudo force. In case of the apparent or observed weight, things we could have already discussed without pseudo. Still, we wanted to entertain pseudo here. Now, pseudo force and connected motion. I'll take one basic example of, Atwood machine. Basic example of Atwood machine, that is, what is an Atwood machine, sir? It's okay if you don't know, I'll be helping you out with that. So there is this situation, there is a pulley, ideal pulley, and we consider ideal pulley right now here. There is M1 mass, M2 mass, say M2 is greater than M1. Okay, so what will happen here? You will say that this pulley is ideal. Okay, ideal pulley is massless plus frictionless. What is the advantage of calling it frictionless or calling it massless? If you call it frictionless, then you assure that tension in string on both sides of pulley, tension in string on both sides of pulley is same, which means T left and T right, instead of considering T left or T right, you consider it to be T naught. Tension in string on both sides of pulley is same. Okay, and what do you mean by massless here? When you want to call it massless, it's angular acceleration, it's acceleration you don't consider basically. So net force on pulley must always be equal to 0. If the pulley is not moving, then also it is 0. If the pulley is moving or pulley is accelerated, then also the net force acting on the pulley, you have to take 0. Means for a pulley, net upward, for an ideal pulley or for a massless pulley, net upward and net downward force must be same. Now, if I consider these things and you look into the diagram, so you will realize M2 will be accelerating down with suppose A0, then M1 being lighter will be accelerated up. M2 being heavier is accelerated down, M1 being lighter is accelerated up. And here I say that suppose the tension is T0. So the tension on this block, let me, stick with this assumption. So if you consider the block M1, so you will say tension here is T, and the force here is M1G, and its acceleration is upward. Here you have M2G, and this is T, and its acceleration is downward. And if you consider this pulley here, the same string which is pulling this M1 up, the same string is pulling the pulley down, and there will be F clamp or clamp reaction here. Since the pulley is considered to be ideal, net upward must be equal to net downward. So I will say F clamp will be equal to 2T. So here I would like to write three things. Here. First of all, if I want to write the equation for block M1, what I can write, and for block M2, what I can write, okay, and for pulley, what I can write. These are the equations which I am trying to write here. So block M1, since it is accelerated up, so bigger minus smaller in the direction of bigger one, T minus M1G is equal to M1 A0. For the M2, since bigger one is downwards, so M2G minus T, that is equal to M2 A0. And for the pulley, you can write net upwards must be equal to net downwards. So F clamp must be equal to 2T. So if you solve all these equations, basically you will get some good results. Those results are, I'll write the first result as common acceleration. The common acceleration, which is A0 magnitude, that is equal to bigger minus smaller, M2 minus M1 into G by M1 plus M2. M2 minus M1 into G by M1 plus M2. That is the first result. Okay. Next is tension. Tension will be equal to 2 M1 M2 G by M1 plus M2. 2m1 m2g by m1 plus m2. And then if you talk about F clamp, that is double of the tension. So that will be equal to 4m1 m2g by m1 plus m2. 4m1 m2g by m1 plus m2. These are the results. That is the introduction to the Atwood machine. Now I want to consider the pseudo force in the Atwood machine. Pseudo force. So I will say illustration 1, example 1. If I consider this here, that this is the pulley, this is M1, this is M2, and this time M1 is greater than M2. Okay, this time M1 is greater than M2, and this is kept inside an elevator, and the entire system is accelerated up with acceleration A of lift. Acceleration A of lift. This is kept inside an elevator or a lift, and the entire system is accelerated with AL. The entire system is accelerated with AL. Okay? That is given to you, AL. Now, you have to write all these results. So, it's very easy writing it here. I will say the first result here, all three results I want to write to see if the entire system is accelerated up. So, pseudo and on everything will be acting down. If entire system is accelerated up, the pseudo will be acting down. If the pseudo will be acting down, the pseudo acceleration, the pseudo force and the gravity are going to be supportive to each other. Don't observe it this way, that acceleration due to gravity is downwards and acceleration of the lift is upwards. They are observing. No, you don't have to see whether accelerations are observing or supporting or opposing. You have to see whether the forces are supporting or opposing. So if the acceleration of the lift is up, where will be the pseudo? Down. And if pseudo will be down in support to gravity, then definitely you have to add them up. If you are going to add them up, you will write the acceleration, common acceleration, that will be equal to bigger one minus smaller one. Here I assumed that M2 is greater than M1. Here I am deliberately assuming M1 is greater than M2. So I will write it as M1 minus M2, bigger minus smaller, into the net acceleration downwards. The gravity is supported by AL. So that is G plus AL. Basically the pseudo force is supporting the gravitational force by M1 plus M2, This is the second one. Okay. Now the second result which I'm writing is tension. Tension will be equal to 2 M1 M2 G. G will become G plus AL by M1 plus M2. Okay, and force, clamp reaction, that will be double of the tension. So that will be 4 times M1 M2 G plus AL, M1 M2 G plus AL by M1 plus M2. All right. Now let us introduce a spring also. Let us talk about a spring also here. Suppose we talk about, say, example 2, and the same situation. There is a K0 spring constant, and this is M1, this is M2, and the system is accelerated down with some acceleration A0 which is less than G. And examiner is asking you, determine the disturbance produced in the spring, disturbance or extension in the spring. Determine the disturbance or extension in the spring. So can I say whatever we have learned in Atwood machine for the clamp reaction, here the spring force is basically the force which is acting as a clamp force. Okay. So what I will say, we all know the formula of spring force, K naught X. They are asking you X. So the situation is again this way, that since here the acceleration is downward, so pseudo force will be upward. Acceleration and acceleration due to gravity are same, but we don't have to look for the direction of acceleration. We have to look for the direction of force. So I will say, when you see that carefully, you realize that the force is acting up. And interestingly, since A0 is less than G, the pseudo force is still less than gravity. So the net dominating force is in the direction of gravity, and that will be given by mg minus ma naught or mal, whatever it is. So I'll directly say here F clamp is basically, or F spring is basically F clamp. F spring is serving as F clamp. Okay. In that case, F spring, I'll write it as K naught into X, and F clamp can be written as 4 M1 M2, and it must be G minus A naught. Once again, acceleration and acceleration due to gravity are in supportive direction, but you don't look for the direction of acceleration. You look for the direction of forces. So pseudo forces supporting the gravity or opposing the gravity, like that you talk about. So from here, X will be equal to, and it is M1 plus M2. So from here, you will say that X will be equal to 4 M1 M2 G minus A naught by M1 plus M2 into K naught. All right. And even I could have modified this question by taking this M1 and M2 in terms of data, 2 kg, 5 kg, and acceleration due to gravity as 10 meter per second square, like that. So right now I'm just making you familiar with the approach, how to deal with the pseudo force. But in our second phase, that is, I have taken relative velocity in 2 phases because it is a crucial topic and technique. I have taken conservation of momentum in 2 phases in this bridge course, phase 1 and phase 2. Again, its importance is very high from, NEET examination point of view. And pseudo force also, it's very useful. There are a variety of cases. There are few conclusions you are supposed to remember. So obviously, I'm going to take this topic also in 2 phases. Right now, this is phase 1 going on. Tomorrow, I will be taking the phase 2 related to the pseudo force. I hope you'll enjoy that too. But make sure, if you haven't, if you have not been that much comfortable, then I really suggest that you, revisit the lecture. It will be available after the live session in the recorded format. You can adjust the speed, and wherever you feel that you are feeling, some sort of discomfort, you can again revisit, you can again listen to me, and I'm repeating the same thing again and again throughout the lecture, so that goes inside your head and stays there till the NEET exam. Okay, if you want, you can take the screenshot of this. Any other doubt? Preeti, regarding your, okay, regarding the cutoffs and everything else, as I said, that we will talk separately, not right now. Right now, we will focus on the pseudo force. All right, chaliye. I hope you have taken the screenshot. Let's move on to the next. Pseudo force on inclined plane. Pseudo force on inclined plane. What is that exactly? So basically, if I take one inclined plane here and I say that, determine that this is an inclined plane, a smooth inclined plane, angle of inclination phi, mass capital M, and there is m naught mass object released from the top. So definitely in our last discussion of conservation of momentum, I told you that it will keep coming forward and downward, and the wedge will keep coming back. Okay. So the situation is that if you just remove this wedge, if you accelerate this wedge with some acceleration, so they are asking you the acceleration of wedge minimum value. They are asking you the acceleration of wedge minimum value, with what minimum acceleration you will remove it, so that what is the wedge acceleration of wedge minimum value in this direction, such that it falls in free fall. The block exhibits free fall, which means the contact force becomes 0, such that the block exhibits free fall. Okay, that is a problem. That is a question for us, such that the block exhibits free fall. Okay, in that case, what is the situation? So first of all, try to understand what examiner is asking you. Exhibits free fall means that is the contact force there. Contact force between block and wedge. Contact force between block and wedge becomes 0. If it is in free fall, which means it is only falling under the influence of gravity. If it is free fall, means it is only falling under the influence of gravity. So under the influence of gravity means no other force, no contact force, nothing. Contact forces are of two types. Contact forces are of two types, friction and normal reaction here in this case. But since the wedge is given to be smooth, there is anyways no friction. So when you say contact force is 0, you want to say the normal reaction N or R is going to be 0. That is your theme basically. The normal reaction N or R is going to be 0. This is the main theme over which we all will focus. That in this question, if they want to say that the block exhibits free fall, basically indirectly they want to say that the normal reaction between the wedge and the block must be made as 0. Okay. So for our better understanding, let me make some gap between the two in order to understand it better. The block and the wedge, I am deliberately maintaining some gap. Anyways, there is no friction. Still, I'll have a habit to maintain some gap like this. Okay. Now, this was accelerated like this, acceleration of the wedge. I can understand this situation. I can, talk about this case study either by standing on the ground or by standing on this accelerated wedge. Either by standing on the ground or by standing on the accelerated wedge. But as I said that slowly I will take you towards the application of pseudo force only. So let it be this way, that let me be the observer on wedge. So if I am observer on wedge, so definitely my acceleration is like this. My acceleration is like this. So if I am an observer accelerated in this direction with the acceleration of wedge is equal to the acceleration of observer. So according to me, there will be a pseudo force applied on the object. There will be a pseudo force applied on the object which will be opposite to the direction of my acceleration. There will be this pseudo force opposite to the direction of my acceleration. It will be equal to the mass of the object. Mass of the object is m0 and acceleration of the wedge, aw or a wedge. Mass, see, if I am an observer, like accelerated somewhere on the block, the pseudo force will be acting in the opposite direction and it will be given by mass of the object and acceleration of the wedge. All right, this is angle of inclination phi. Now, if we can easily resolve it here. So I will say that, this angle will also be phi. These are alternate interior angles. So this will be m0 a wedge, cos phi, and this will be m0 a wedge sin phi. m0 a wedge sin phi, m0 a wedge cos phi, m0 a wedge sin phi, ma sin phi, ma cos phi, like that. And there will be a normal reaction. There will be a normal reaction N or R, which you are interested to make it 0. Which you are interested to make it 0, then only you will call it a free fall motion. No. And here there will be another mg will also be there. So I should draw it this way, that this is mg, this is mg. I will say this component here, we all know that comes m0 g sin phi, and this component will be m0 g cos phi. So for normal reaction to be 0, or in case of free fall, what you will say? This case, this plus this must be balancing, this plus this. Normal plus, this will be balanced by this. So here I can write that m0 g cos phi, because according to the observer, you are talking about, according to this observer, you can't see the block moving like this. According to this observer, you can only see the body moving like this. According to the observer standing on the inclined plane, observer can see the body slipping along the inclined plane. The observer can't see the body moving like this, perpendicular to the incline. So perpendicular to the incline, the forces must be balanced, which means m0 g cos phi will be equal to m0 a wedge sin phi plus normal reaction N or R, where this normal reaction for the free fall must be 0. So from here, m naught will also be cancelled. Acceleration of wedge will be equal to g cos phi by sin phi, or better way that can be written as g cot phi. G cot phi. So this is the value, minimum value of acceleration of the wedge, minimum value of the acceleration of wedge for which the block will exhibit free fall. If you provide some acceleration greater than this, as it is minimum, if you provide some acceleration greater than this, then definitely the wedge will be removed and the block will still be exhibiting free fall. Okay, right? So what did I do? I had two choices to solve this situation. One choice, I could have stayed on the ground and then analyze the situation, which is a normal way of doing it. Another choice is become an observer and stand exactly over the inclined. Since the inclined or wedge was moving towards the left, so you as an observer will observe the block and there will be a pseudo force acting towards right. Mass of object, acceleration of the observer. But according to this observer, the observation is that the block can be slipping down the incline, but it should not be moving perpendicular to the inclined surface, which means perpendicular to the inclined surface. I have balanced all the components in order to get the desired result. All right. I would like you to review and remember this case study, this conclusion you must remember. In fact, all the case studies which we have dealt with, today in pseudo force and which we are going to deal in pseudo force phase 2 tomorrow, all the case studies you must try to have on your tips. Just like in conservation of momentum phase 2, I gave you a one-shot recap of whatever you have discussed in phase 1 and then I continued the procedure. Similarly, tomorrow morning when I'll be meeting you, I will be giving you a one-shot quick recap of whatever we have discussed today. I'll emphasize on some minor points and then we will continue our journey of pseudo force up to the completion tomorrow itself. So by tomorrow, we are going to have a very strong command on pseudo force, including the predictable problems, which I am expecting to be coming in the NEET 2026 exam. So we will not only strengthen our fundamentals, but we will also try to be familiar with all the problems that may come in the final exam. All right. So for now, this is it from my side. And I hope that you will review everything nicely. Take care of your health, enjoy your good time with your friends, family. It's important, but at the same time, do follow the rule of revision. Whatever you are learning from morning to evening, make sure you revise it thoroughly before you sleep. Okay, stay smiling, enjoy the day, all the best.